Hey everybody, today we're trying to find the constant term of this cubic equation. So we're trying to find P, trying to determine it. Now, we're given some specific information about the nature of the real roots. There's three of them. There's three distinct real roots, and also this piece right here is necessary, at least for this problem. Two of the roots are additive inverses. For example, minus 7 plus 7 equals 0. That's what we mean by additive inverses, right? You get the additive identity when you sum them up, okay? So two of them are additive inverses. So let's see what we can do with that additional structure right here. Just three distinct roots wouldn't be enough to get you the value of P. So let's see what this does for us. Now, this part right here is just a very famous or common competition deal where we're trying to use something called Vietas. We're given A, B, and C as roots of this given polynomial, and not necessarily distinct as far as the way this plays out down here. Now, when you expand this out, you get minus the sum of the roots is the coefficient of x squared, and then this structure right here, the product of all the roots summed together is the coefficient of x, and of course you have minus the product of the roots at the very end. So in other words, this part right here, I'll just write it right here, will be P. You can write it right above here, minus ABC is going to equal to P as far as equating the coefficients go. All right, now let's keep moving here. So if we equate the coefficients, notice we have minus 18 is the coefficient of x squared. So we can set it equal to the coefficient of x squared right here in this expansion to get this statement here. Now right here, let's see what we can do with this. Now we can take A and B if you want to do B additive inverses. You can pick any of them and it will work out. A and B will work out. So we'll try that. We'll have, this would be the same thing as AB plus, now you can write it one of two ways. I'll just write it like this. AC minus AC. Right, folks? Because we're taking A and B to be additive inverses. So B is equal to negative A, or you could write it however, you could write it slightly differently if you wanted to. But that's equal to this, but that just says that the AC terms cancel, and of course you have AB equals to minus 25 over 9. Okay, so it's pretty clear that we can take, this would imply that A, you can take A to be plus 5/3 if you want, or the other way around. But A would be equal to plus 5/3, 5 over 3. And B would be minus 5/3. So you see, this is favorable because these two guys sum to 0, which of course is useful in terms of simplifying the problem. Okay? Now, so we know that, what else do we have here? So we're doing good here. We have A and B equal to 5/3 and minus 5/3 respectively. Okay, now we know that from this statement right here, that would be the very same thing as saying minus, see, A and B are additive inverses, so you would have minus 0 plus C equals to negative 18. It's kind of nice, isn't it, folks? Works out nicely here. And so what we get here is C is equal to 18. So we found the zeros, or the roots. C is equal to 18, and you see what A and B are right here. Now we also know from this statement right up here, let me write this down, that P is equal to minus ABC. Okay, folks, but you can see with these assignments here that that's going to just be 50, right? Because you'll have 3 times 3, which is 9 into 18 is 2, and then the minus sign here will be killed by this minus sign, so you get 50. Again, folks, I'd save me a step of writing it down, but since we've written down what A, B, and C equals, it's very straightforward to substitute. This minus sign will kill this minus sign, And the rest of the arithmetic's very easy. 5 times 5 is 25. And then 18 divided by 9 is 2. So you end up with 50 here. So that's our solution, folks. P is equal to 50. That's an example of Vieta's formula combined with just this simple notion of additive inverses. Okay, so let's write this down. P is equal to 50. And got to have some supper. Take it easy.